Today we will discuss about sound lesson. Before discuss about that sound, first we will learn about that waves. What is meant by wave? Wave is nothing but a disturbance created in a medium. So we are using the word in this lesson, medium especially. In science we are using that, not the substance. Instead of substance, we are using the word medium. So if we create a disturbance in a medium, then it will cause us to produce a wave. So for example, if you take a glass of water and if you drop a stone in it, then you can observe that some waves will be formed on the surface of water. When I was talking here, then I will create a disturbance in the surrounding air, so it will create some waves. So wave means nothing but what is a disturbance created in a medium. When I was hit this board, I create some disturbance in the board, it will produce some wave in this one. So waves are produced by that disturbance created in a medium, and these waves are classified into mainly different types. In that, one is longitudinal wave and another one is transverse wave. So waves we have classified into two types. One is longitudinal wave and another one is transverse wave. So what is meant by longitudinal wave? For example, if we take an object and a metallic strip is there or an iron scale is there, just I will plug the iron scale. That means when I was pull the iron scale and leave it, then what will happen, that it will vibrate like this. It will vibrate like this. Now what will happen, that what will create it? So now you can observe that starting in it, suppose starting here like this, in its surrounding some molecules are there, air molecules. When you plug that one, when it pushes the air towards right side, then these molecules will move towards right. And when it come back, when it goes forward, these molecules will push us like this. They will push us like this, and the molecules comes like this, very close to each other. When it come back, you can observe that what is happened, that when it come back like this, now the molecules here are very, very less. So the density of particles are more is here, then it is called as compression. And the density of particles is less is called rarefaction. So observe that what I said. Just I have taken iron scale and I have plugged the iron scale. Then it is vibrating like this. When it vibrates like this, what happened, that when it moves towards right side, it pushes the nearby air molecules, and here also some air molecules are there. Now the density of air molecules will become more at a particular region. And what this is called as? We call it as compression. We call it as compression. And when it come back, here the density of particles are very less. They are called as rarefaction. So when you plug an iron scale, it will create in the air like this. Now what it happened, that here observe that now these particles, not only here, they will be vibrate like this, and the nearby particles also they will vibrate, and here the density of particles will be decreases, and here the density of particles will be increases. So like that, compression and rarefaction, the waves will be propagated. So this is the direction of wave. Wave is moving towards right side, and the vibration of the particle, how the particles are moving like this, and the wave is propagated in this direction. And the direction of the propagation of wave and the vibration of the particles, both are in same direction. That type of waves are called as longitudinal waves. These waves, what we call it as longitudinal waves. So what is meant by longitudinal wave? The vibration of the particle is parallel to the direction or along the direction of propagation of wave. That waves are called as, what we call it as longitudinal waves. So what is longitudinal waves means? The vibration of the particle is parallel to the direction of propagation of waves. That waves, what we call it as longitudinal waves. So whenever longitudinal waves are propagate, they will create compression and rarefaction. Compression and rarefactions will be formed whenever longitudinal waves are propagate. And example of longitudinal waves, sound is the best example of longitudinal wave. Sound is a good example of longitudinal wave. So how the longitudinal waves are propagate? Longitudinal waves are propagate when the vibration of the particle is parallel or along the direction of propagation of wave. That waves are called as, what we call it as, longitudinal waves. So this is about that, what is longitudinal wave. An example, sound is the best example of longitudinal wave. And next, another type of wave is also be there. What is that is? Transverse wave. How the transfer wave is formed? Let us discuss. So now I will take that, what that is. This is a still water. If I drop, so this is a bucket of water I will take, and it is still, means it is at rest. Now I have dropped a stone like this. When I drop the stone like this, just it will be going down. Now you can observe that what will happen that while it is going down. So you can observe that the starting when this it's touch the surface of the water, this particle will comes down, and the nearby particle comes down, another particle will comes down, and they will be vibrate like this. Another particle is going up like this, another particle is going up like this, another particle is going down like this. So like this, what is that is? The wave is propagate. So now observe that here what is happened, that if you join all these points, you will get a shape like this. So how the transfer waves are formed means, observe that here when you create a disturbance in this surface of water, now what is happened that the vibration of the particles takes place. How they are vibrating? They are vibrating like this, or they are oscillating like this. When the vibration of the particle is vibrating like this and the wave is moving in this direction, this is wave direction, and the particle vibration direction is like this. This is the particle is vibrating like this, and wave is moving towards right side, but the particle is moving like this. And here the vibration of the particle is perpendicular to the direction of propagation of wave. So wave is moving in this direction, vibration of particle is in this direction, and the vibration of the particle is perpendicular to the direction of propagation of wave. That waves are called as transverse waves. So transverse waves means, what is that is? The vibration of the particle is perpendicular to the direction of propagation of wave. That waves, what we call it as transverse waves. Example of transverse wave, light waves. Light will traverse in the form of transverse waves. So light will propagate in the form of transverse wave. So what is that is? Main two types of waves we learn. One is longitudinal wave, another one is transverse wave. Longitudinal wave means how the longitudinal waves are formed. The vibration of the particle is parallel or in the same direction of the propagation of wave. Then the waves are called as longitudinal wave. And whenever longitudinal waves are formed, it will create as compression and rarefaction. Compression means the density of particles are very close, is called as compression. Rarefaction means the density of particles is very less, is called as rarefaction. Now if you see that next type of waves are transverse waves. Here the vibration of the particle is perpendicular to the direction of propagation of wave. Wave is propagate in this direction, but the vibration of the particle is like this. Then that waves are what we call it as transverse waves. Vibration of the particle is perpendicular to the direction of propagation of wave, that is called transfer wave. Now in this transfer wave, this part is called as, in this wave this part is called as crest, and this is called as trough. Crest and trough. Whenever transfer waves are formed, it will create crest and trough. Crest and troughs are formed. When transverse wave is propagate, it will create crest and trough. It will propagate in the form of that crest and trough. Example of transverse waves, light waves. So these are the main two types of waves. So what we have to learn from this in this lesson. Now let us discuss about that. what is meant by sound? So first we learn about that what is that waves and the types of waves. Now what is meant by sound? Simply what is meant by sound means simply we can say that it is a form of energy. Sound is a form of energy. How can you prove that sound is a form of energy? Energy means the capable to do work. What is the work done by the sound? It's a simple activity. We can understand that what that is. Sound is a form of energy. For example, if we take a cylindrical shape object, both sides in between hollow and both sides it is open. I have considered a cylindrical tube, both sides it is open and it is hollow. This end I have covered with a rubber balloon. A rubber balloon, by using it I have covered completely with it. Now I will fix a small mirror here. Small plane mirror I have fixed. And I have focused a laser light. With the help of a laser light is passes through it. And we learn in that light lesson, it will be according to laws of reflection, it will be reflected. It will be reflected, and on some wall you can able to see that laser light means a small dot. I think we are playing with the laser lights. That a red color dot, you can observe that when I focus the red color dot to that mirror, it will be reflected and we can see that on the wall I can see that red light. And I have fixed the laser light. I am not able to move this one and also this cylinder. Now this end I am shouting here. Just a person will come and produce some sound. He has produced some sound and loudly, and he has shouted. Now what you will observe that this dot will be moved. This laser light will move now. When an object will move, there is a work is done. When there is some work is done on this object, then only this object will move. So it is vibrating and it is moving. Because of that we are not able to apply any force on that one. Just we are shouting near this one. When you shout there, what happens? It will be vibrate. So the sound is causes to move this laser light. So that's why we can easily prove that by using this simple activity. Sound is a form of energy. Sound is a form of energy. Remember, sound is a form of energy. And how the sound is produced. Now let us discuss about that. How the sound is produced. Sound is produced by the vibrating of an object. When an object is vibrating, it will produce sound. An object is vibrating, then it will produce sound. So, sound is produced by the vibrating of an object. When I was talking, when I was keep my finger near the throat, I feel the vibrations. Sound is produced because of this. Vibrations are there. You can feel the vibrations. You have some, in school some of the bells are there. Now you can observe that some iron material, they will hit with some other material, and if you touch that one you can feel the vibrations. And you have cycle bell is there. If you ring the cycle bell and if you keep your hands, you can feel the vibrations. So vibrating, any object which is vibrating, it will cause us to produce sound. Vibrating of an object which will produce the sound. Sound is produced by that. How the sound is produced? By the vibration of the object. If an object is vibrating, what happens? It will produce the sound. So sound is produced by the vibration of an object. Now let us learn about that. What is that is? How the sound will propagate. How sound will travel. How sound will travel. Already we learned that about the waves. Different types of waves we learned that. In that, sound will travel in the form of which waves? Longitudinal waves. So remember that sound will travel in the form of that which type of waves means longitudinal waves. That means while it is in this motion, it creates compressions and rarefactions. These compressions and rarefactions will travel and they will cause us to produce the wave. And so many are things that I have asked that anyone to draw a wave means just they will draw a wave like this. Yes, it is correct only. But remember, wave is not, don't think that always in the form like this. So this is also a wave. See that this is also a wave. What is this one? Sir, what is these long lines? These are nothing but what is this is compression, and this is rarefaction. So wave is in the form like this also we can represent. Sir, always this one represent like this. Can we able to represent like this? Yes, we can able to represent that longitudinal wave also like this. How it is? For example, if we take this point is the mean position. Mean position means, just I will explain that some of the concepts related to pendulum. I think you have learned that a simple pendulum. A simple pendulum is made up of that a metallic ball is called bob. A metallic ball is called bob. When it is suspended with the help of an inextensible thread, that is called as that, what is that is simple pendulum. When you take a simple pendulum and it is in this position is called as that mean position. We call it as that this position is, what is this position? We call it as mean position. Mean position. And if you start the vibrations or oscillations, I have started, just I have pushed this pendulum. Now you can observe that what is this is, it will be oscillate. It will oscillate like this. To and fro motion is called as, to and fro motion is called as that, what is that is oscillations. So when it is moving towards right like this, it reaches a maximum value. The maximum displacement it is covered from its mean position is called as that, this is extreme position. This is extreme position. And again it will come back to mean position and return back to what is that is extreme position. Extreme position. So now oscillations, here it is oscillating. Now observe that here, from here to here it reaches the maximum displacement. It again comes to minimum, again maximum, this is minimum. Mean position is considered as that minimum. So like that, this is the line I have considered that this is the mean position. This horizontal line represents that, what is that is mean position. Mean position this is. From this mean position, just I want to draw a graph. This is what we call it as compression. Compression means the density of particles is more. Just I will take the density here. So the density of particles will be increases. This point is called as, what is that is compression. After compression, what you will get? Rarefaction. Rarefaction. So compression after, what is that is? The displacement will becomes minimum. This is rarefaction. And again compression, again rarefaction, compression, rarefaction. So all these points if you join, you will get a shape like this. So we can represent this longitudinal wave also like this, and this is compression, rarefaction, compression, rarefaction. So like that longitudinal waves are also we can represent with the help of like this. So now we can understand that what is that is. Sound is a form of energy, and it is, sound can be produced or sound can be created by the vibrating of an object. If an object is vibrating, what happens? It will produce the sound, and the sounds are represented, sound waves are longitudinal waves or transfer waves, both we can represent like this. So this is what is meant by sound.